processor. Before your program gets compiled, it actually runs through a phase called pre-processing. It's almost like there's a language on top of the C language that runs first, and it outputs the C code, which then gets compiled. We've also seen this to an extent with hash include. That's the C processor where it sees that directive, it includes the named file right there, just as if you type it in there. And then the compiler builds the whole thing. But it turns out it's a lot more powerful than just being able to include things. You can define macros that are substituted and even macros that take arguments. So I have pre-read this article while I was recording that video, that failed recording of the video. So I might skip some stuff. Skip as in the sense that I will skim some stuff which I already know, right? But I will explain to you guys. So technically you don't lose anything. Let's start with one we've already seen a bunch. This is of course a way to include other sources in your source, very commonly used with header files. While the spec allows for all kinds of behavior with hash include, we're going to take a more pragmatic approach and talk about the way it works on every system I have seen. We can you can split header files into two categories, system and local. Things that are built in like studio.h and studiolib.h and map.h and so on, you can include with angle brackets. And so the angle brackets tells you, hey, don't look in the current directory for this header file, look in the system might include directory instead. So that's what the angle brackets say. Because in the current directory, if you had to look in the current directory, you would have to do the double quotes. Yeah, like I said, in relative directories using forward slash and dots. Yeah, don't use a backslash for your path separators in your hash include. It's undefined behavior. Use forward slash only, even on Windows. In summary, used angle brackets for the system includes and use double quotes for your personal includes. Now, simple macros. A macro is an identifier for that gets expanded to another piece of code before the compiler even sees it. Think of it like a placeholder. When the preprocessor sees one of those identifiers, it replaces it with another value that you have defined. We do this with hash define, often read pound define or perhaps hash define, but rarely, if ever, octothorpe define. Here's an example. So am I going to do the example? Sure, for you guys, I'll do anything, right? NVM. So define dot c hash include studio dot h, right? And hash define hello world, right? Hash define pi 3.14. So as you can see, there is a way to make constants in C. Oh, oops. I guess I will do that as well. Int main void printf s f slash what the hell f. Oh my god, what's happening there? I think I'm pressing enter slash n hello and pi cc define.c and do this hello world. Okay, did replace that. Wait. Oh my god. Oh f. Oh my god. Oh, 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 oh. And there you go. Now on lines 3 and 4 we define a couple macros. Wherever these appear elsewhere in the code, it will get replaced. That's about it. Yeah, they don't have a specific type. You can just put anything that runs. Is that the thing is that they will be replaced with wherever the macro is defined, not defined, literally wrote in the source code. Yeah, this as well. Conditional compilation. It's possible to get the preprocessor to decide whether or not to present. Yeah, we said, not we read, like I skimmed through the hash define extra happy, right? Yeah, this is used to use conditional compilation. If this is defined, run this code, otherwise run this code. Yeah, so first of all, so I'm not gonna, I'm gonna read this. Look at that. Hash include studio.h, hash define extra happy, if ndf. In that example, we define, I'll do this. If def.c, that is not the thing. Move if def, what the hell? If def. What do you mean? Oh wait, I forgot that I didn't save it. So yeah, stdio.h hash define extra happy int main void, right? And then we come to hash if def extra happy, and then print f. I am extra I'm extra happy, boom boom slash oops slash n, and then yeah, if def and if, right? Now if I do print f, okay, no, I am extra happy. You know what, I'm just gonna say I'm happy. I'm happy for you guys watching this video, right? And cc if def.c, and if I put I am extra happy, I am happy, right? Like, the thing to note about is that this thing replaces the code if extra happy is defined. Now if I delete this and do this and compile it, look what happened. What's going to happen? I am happy is the only one thing printed. So that's what macros do. Replace the code you want to replace. In that example, we define extra happy to be nothing, but it's defined. Then we get that. Then we do that. It's also this happens at compile time. Yeah. These things happen at compile time, not at runtime. It is before the pre-processing step. The code actually gets compiled or removed depending on the condition. This is in contrast to a standard if statement gets evaluated while the program is running, if not defined. So like the little antithesis of if def. Oh, you guys don't know what in antithesis mean? I'll show you. Yeah, this is the not software. This is the project I was developing for C. Exact opposite. How yeah, I'm proud of this, man. And it's something too that I created in C. That too in a week, and yeah, that too in a week, and reading like not. What am I saying? That too in a week. That's what I'm meant to say. I try to add a lot of stuff to say, but in the end, I'm like, I don't have to say it all. I say all these things. So stupid. Beach, not dev. I want to erase that, not erase, replace that sound. I think it's from Kitty that's coming. Yeah, I use Kitty, guys. If you didn't know, I mean, it's the symbol is right there. What am I saying? Remove, not remove, clear. Okay, so there's also the negative sense of if defined, if not defined, or hash if and def. Now we would change the previous example of output different things based on whether or not something was defined. So if defined, if n defined, the thing will not be defined and this code will be put into the file. I'm not going to do this because yeah, we'll see a cleaner way to do that in the next section. Tying it all back to the header files, we've seen how we can cause header files to be included one time by wrapping them in preprocessed directives like this. Exactly. This demonstrates how a macro persists across files and multiple hash includes. If it's not yet defined, let's define it and compile the whole header file. But the next time it's included, we see that my header h is defined, so we don't send the header file to the compiler. It gets effectively removed. Oh, I did say in this video while I was reviewing this video where this tip existed, that the first time we encountered this tip, I looked through the video. Now I think I get why this is there, like why one time the header file is called. I believe is because that conflicts, like one time the code is already given, and if I call somewhere else as well, and because it's like a same file, right? Because the compilation is trying to at the compile step, will compile everything, it'll create the objects, it'll all link the objects as well, right? So that's how the thing turns from source code to assembly or the machine code, right? So maybe due to namespaces or conflicts of names, probably that's the reason why there's only one header to be included, even though hash include does multiple includes of the same file. But if this is there, if it's n defined, if def, if this satisfies, then only the code is inserted, otherwise the code is not inserted. I think that's the reason why this tip is used. If you guys think otherwise, or if you guys think I'm wrong, please put it in the comment section below. I really want some professional who is in professional C developer to really review these videos. But I know that these videos are 1 hour long and stuff, so they won't have the time to review it. Hopefully they do, but yeah. But that's not all we can do. Else, there's also an else that we can throw in the mix. That's more the previous example. Yeah, I'll do else because else is a new keyword. I'm going to do it in this itself. Now hash define extra. Yeah, I'm going to do a regular. Right? Hash else. Oh. Hash else and then p. I'm happy. Else I'm happy. Right now, what we're going to do is I'm going to do this cc if def.c. I am happy. There you go. Yeah. Else if. Now elif def, elif end def. This feature is new in C23. What if you want something more complex? Though perhaps you need an if-else cascade structure to get a code built, right? Luckily, we have these directives at our disposal. We can use elif def for else if defined mode def. Now, on the flip side, you can use elif end def for else if not defined. So that's that. General conditional if hash elif. Now this works very much like if def and hash if def directives, in that you can also have an else and the whole thing wraps up with end def. So yeah, the only difference is that the constant expression after the if must evaluate to true, non-zero for the code in the if to be compiled. So instead of whether or not something is defined, we want an expression that evaluates to true. So happy factor is 0 or happy factor is 1. So it's the same thing as if defined, but if that expression evaluates to true. It's like our own if else statement in C, but for macros. Again, for the unmatched if clauses, the compiler won't see those lines. For the above code and the preprocessor gets finished with it, all the compiler says is this. One hackish thing is used for is to comment out large numbers of lines quickly. If you put an if 0, if false at the front of the block to be commented out, and an end if at the end, you get this effect. Yeah. What if you're on a pre-23 compiler and you don't have elif def or elif end def directive support? How can we get the same effect with if? That is what if I wanted this. If def, elif def is not there, is not supported. So how could I do it? Turns out there's a preprocessor called defined that we can use with an if statement. So these are equivalent. If defined foo, if foo is defined, if defined foo parentheses option, as are these. So it turns out of all that we can use with an if statement. Okay, elif defined. Oh yeah, we don't have elif defined, so we do if and defined. This is an operator, preprocessor operator code. Notice how we can use the standard not logic, not operator for not defined. So what this does is simple. If foo is defined, run put x equal to 2. If else if bar is defined, put x equal to 3. In this case, what it does is if def foo is defined, do this, but we cannot repeat the hash if def, right? So what do we do? Hash if foo is already defined, if foo is already defined, then check this, right? And parenthesis is optional as well, or if not defined. So we're back in if land and we can use elif with impunity. This program call can be replaced with elif defined bar. There you go. If defined foo, see, defined is I think, yeah, if defined is a expression that evaluates to true if the foo macro has been defined or bar has macro has been defined. So that's what the defined preprocessor operation does. Then if an elif looks at that expression and be like, ah yes, this is true, execute this code. It's not true, don't execute this code. So losing a macro, hash endf. If you define something that you don't need it any longer, you can undefine it with hash endf. So am I going to do this again? Nope, because yeah, I don't want to do it. I don't want to do it because you guys make it makes sense, right? Endf goods. Now the standard defines a lot of built-in macros that you can test and use for conditional compilation. Let's look at these. Now I'm gonna do this because I like doing this. That's why. So there are mandatory macros that you can test and use for conditional compilation. Let's look at those here. So mandatory macro mandmac.c. I believe how many articles are there? I think there's 10 or something. Yeah, there's 12. So we reached 4. No, we didn't reach 4. The embed directive is, there's 12 of them. So yeah, built-in macros, mandatory macros. So I want to do this. So date is the date of compilation, like when you're compiling this file in mmddyy format. The time of compilation in HHMMSS format. A string containing this file's name, the line number of the file this macro appears on, the name of the function this appears in as a string. What does that give? This isn't really a macro, technically identifier, but it's the only predefined identifier and feels very macro-like, so I'm including it like a wrapper. Defined with 1 if this is a standard C compiler. This will be 1 if the compiler is a hosted implementation. A hosted implementation basically means you're running the full C standard, probably on an operating system of some kind, which you probably are. If you're running on bare metal and some kind of embedded system, you're probably on a standalone implementation. So hosted and standalone. So yeah, hosted. This version of C, a constant log int in the form YYYYMM capital L, example 2017-10. So that's the version of C. So let's put it all together, right? Hash include slash n. So this function is known as, the main is going to be a func. Now this file name is known as printf. This line is known as, I mean not line, this line number. Oh, whoops, that is not what I want. Compiled on compiled on oh my god, I'm pressing tab, I'm pressing enter. Date, right. and C version. And Mac, boom. So this function main line 5 June 23 23 23 11. So the output on my system is error are particularly useful to report error conditions and messages to developers. The assert macro in master.h uses these calls to call out where in the code the assertion failed. Now STDC versions, in case you're wondering, here are the version numbers for different major releases of the C language. Yeah, I don't give a shit. Yeah, not the macro did not exist originally in C89. As note, that plan is that also note that the plan is that the version numbers will basically increase, so you could always check for say at least C99 with this thingy. Now optional other macros are there, macro with arguments. Now macros are more powerful than symbol substitution, though. You can set them to take few arguments that are substituted in as well. A question often arises for when to use parameterized macros versus functions. Short answer, use functions. But you will see lots of macros in the wild and the standard library. People tend to use them for short mathy things and also for short features that might change from platform to platform. You can define different keywords for one platform or another. Now macros with one argument. Let's start with the simple one that square a number. Now this is going to square x, x square, x square. Now what happens here, I'm not going to do this. It's an exercise left to you guys. You guys have to do this. So what happens here is, this 12 will go here. 12 into 12 will get 144. Nothing goes wrong. I was just simply dramatic. I was simply dramatizing it. So what's that saying is everybody will say square with some value, replace it with that value itself. So line 7 will be doing it out. Now converge though, but we made an elementary error in that macro, one that we need to avoid. Let's check it out. What do we want to compute? 3 plus 4. Now what happens here is 3 plus 4, 7, and 7 squared should 49, right? That is not what's going to happen. What's going to happen is 3 plus 4 will be kept here. 3 plus 4 will be kept here, right? So 3 plus 4 into 3 plus 4. So 3 plus bottom mass rule 12 plus 4. So how much it is? 7, 19, you will get the answer. There you go, 19. So this happens because they, like we said, this macro substitution, everything is happening at compile time. It's not happening at runtime. So what happens? We just take the piece of code, not piece of code, yeah, the piece of code inside the brackets, inside the parentheses, and replace it with the x, with the parameter. So the common way that you should do automatically do it every time you make a parameterized method. So how would you do this? It's already said it, x here, x here. So what happens is that 3 plus 4 parentheses into 3 plus 4 parentheses. So those two get added together, and 7 into 7, 49. But we actually still have the same problem, which might manifest if we have a higher presence operator than multiply nearby. Yeah, so we just have to do a bigger one, close it fully. The problem to put in the wrap the whole thing in additional parentheses like so. Just make it a habit to do that when you make a math macro, and you can't go wrong. Yeah, macros with more than one argument. You can stack these things as much as you want as well. So if you can see WH, so this is the macro. So for x, for the quadratic formula, just in case you don't have a top of it, just yeah, this is the thing, and plus and negative, which is crazy. Also notice the plus or minus in there, indicating that there's actually two solutions. So we have chord P and chord M. I don't know why it's called chord M, but yeah. So that's it. So that gets us some math, but let's refer. Excuse me, guys. Yeah. One more that we can use as arguments to printf to print both answers. So yeah, so but let's define one more that we can use as arguments to printf. Yeah, code ABC and code P and code M. That's just a couple values separated by a comma, and we can use that as a combined argument of sorts to printf like this, right? So what happens here is code to 10.5 gets this whole thing gets replaced with these two guys, and these whole two things get replaced with these guys, and then that two equations are placed in there with a comma in between, and then in runtime it's going to calculate it, and it's going to calculate the other one as well, and then they're going to have two numbers here, and that's how we get the output. This is also left as an exercise for you guys because I don't want to do it. It's just the basic principle of substitution with parameterized arguments taken to the next level, right? Macros with variable arguments. Now this is something I'm interested into. There's also a way to have a variable number of arguments passed to a macro using ellipses after the known named arguments. When the macro is expanded, all of the extra arguments will be in a comma separated list in the va_args macro and can be replaced from there. So let's see. Ten times A plus 20 times B, and then it's going to just replace V args. Slash n 5 4 3.14. So yeah, what this gonna do is it's gonna replace A, B, and then so what it's gonna do is it's gonna replace this whole thing with here. So that would be 10 into 5 plus 20 into 4. So that is 80 plus 50. So that is 130. 130 is going to be the answer here. Wait, it's 3 values, right? No, there's 4 values. Yeah. No, yeah. This will combine into this, and you will get 130 as this value, and the floating point and the high and the 12 is here. There you go. So substitution takes place, yada yada. Stringification. Already mentioned just above, you can turn any argument into a string by preceding with a hash in the replacement text. For example, you could print anything as a string with this macro. Okay, nice. Substitution lead to this thingy. Let's see if we can use this migrate to greater effect so that we can pass any invariable name into a macro and have it printed out its name and value. So online we get the following macro replacement A. Oh yeah, print int value x printf percentage s equals percentage t. So what this does is it takes in this, makes it into a string, and you will get a is equal to whatever the value is a. So it's very easy, very good for, I guess, debugging. Concatenation is hash together 1 times, right? Now multi-line macros. It's possible to continue a macro using this dash line, and yeah, you can use braces as well, because this is essentially what it's doing is put all this code in place of this. That's what it's doing. Put all of this code, not the whole of this code. A couple things to note here. Escapes at the end of every line except the last one to indicate that the macro continues. The whole thing is wrapped in a do while. Yeah, if it sees a slash n instead of a slash, right, it knows that the define is stopped. Otherwise, you have to keep on adding slashes. The whole thing is wrapped in a do while loop with the squirrely braces. The later point might be a little weird, but it's all about absorbing the trailing semicolon. The coda drops after the macro. The whole thing is wrapped in a do while loop with a squirrely braces. Yeah. So at first I thought those curly would be enough, but there's a case where it fails if the coder puts a semicolon after the macro. Yeah, this makes sense because in this case, where yeah, foo of I, what I is equal to 0, right? I gets here and I plus plus. If they put colon here, like if I had to put colon here, because you typically put colon after the while condition, right? What's going to happen is that you get two columns because it got replaced. Yeah. So wrap that multi-line macro with a do while. So I want, so that is the reason why, I guess you can do this without putting a do while as well, right? You can just not put in a semicolon. Oh, okay. So it's not double thing. I forgot about the curly braces. I forgot about the curly braces. Yeah. The semicolon, you have to put the semicolon there to indicate that that is the end of the text, end of the sentence. Otherwise, this will give you firing, I believe. You know what? Let's just try that. What do I call this? Mult, not mult, semi mac.c and include stdio.h has define foo x right? So wait, I can just do like this, right? No, I can't do it like that because that is not the problem here, isn't it? I want to see if I can do it with the compilation step will not work, but the pre-processing step is there, right? Oh, right. Okay, I don't know why this is here. Oh wait, it's a bad face. It's a sad face. Yeah. Semi-mac, do this. It didn't print anything. Yeah, it's not supposed to print anything. Oh wait. So that means so compile that. Yeah, there you go. So that means it does work. It's not necessary you have to put semicolon here because it already knows that the code block is there. Right, but it will be good for you guys to do while. So what do while 0 does is it will execute the code one time and just while 0. You can do that or you can do what I did. Don't put semicolon here. Example, an assert macro. So adding asserts to your code is a good way to catch conditions that you think shouldn't happen. C provides assert functionality. It checks a condition and if it's false, the program bombs out telling you the file and the line number on which the assertion failed. But this is wanting. First of all, you can't specifying an additional message with the assert. Secondly, there's no EC on off switch for all the asserts. You can address the first with macros, obviously. Basically, when I have this code, when I do this, if I want something like this to happen, assuming the assert is on line 220, if x is less than 20, not 20, then fprintf standard to error, and exit 1, right? We can get the file name out of the file macro and the line number from the line. The message is already a string, but x is less than 20 is not, so we'll have to stringify it with percentage. We can make a multi-line macro by using backslash escapes at the end of the line. So yeah, he used the do while method. If not C, that is the condition, fprintf standard everything and hash C. Now, and that works. If I run this, I get this output, right? Very nice. The only thing left is the way to turn it off and off. You can do that with the conditional compilation. So hash define enabled 1. So I'm going to explain this fully thing. So hash include take from studio.h and stdlib.h. We assert enabled 1. If assert enabled is defined, is not defined, it's 1, it's true, the compiler is giving me 1. Hash define the assert, this all do it. Else hash define assert, empty macro will not if not enabled. Yeah. So do all this shit. If not, then do empty shit. Like assert s20. I have no idea why they use stdlib.h. Oh yeah, it's because of this, the exit function. That's why. So the error directive. This directive causes the compiler to error as soon as it ceases. Commonly it is used inside a condition to prevent compilation unless some prerequisites are missed. So yeah, if it's not, I really need IE to compile, sorry. Yeah. The hash embed directive, new in C23 and currently not yet working with any of my compilers, so take this section with a grain of salt. The gist of it is that you can include bytes of a file as integer constant as if you type them in. For example, if you have a binary file named foo.bin that contains 4 bits with decimals 11, 22, 33 and 44, you do this. It will be just as if you type this. It's a really powerful way to initialize an array with binary data without needing to convert it all to code first. The preprocessor does it for you. A more typical use case might be a file containing a small image to be displayed that you don't want to load at runtime. So if you use angle brackets, the preprocessor looks in series of implementation defined places to locate the file, just like hash include would do. If you use double quotes, the result is not found. The compiler will try it as if you are using a last desperate attempt to find the file. Hash embed works like hash include in that it effectively pastes values in before the compiler sees them. This means you can use it in all kinds of places. Yeah, hash, you can put it there, you can put it there, all. Now, are these always bytes, meaning they'll have values from 0 to 10 inclusive? The answer is definitely by default yes, except when it's no. Technically, the elements will be char bits wide, and this is very likely 8 on your system, so you get that 0 to 255 range in your values. They'll always be non-negative. Also, it is possible that an hash embed parameters. There are all kinds of parameters you can specify to the hash embed directive. Here's an example with yet unintroduced limit parameter. So yeah, but what if you already have limit defined somewhere else? Luckily, you can put the underscore, the double dunder around the keyword and it will work the same way. Now, what's this limit thing? The limit parameter, you can specify a limit on the number of elements to embed with this parameter. This is the maximum value, not an absolute value. If the value that's embedded is shorter than the previous value, only that embed will be imported. The dev random XML above is an example of the motivation for this. In Unix, that's a character divisor that will return an infinite stream of parity random numbers. Embedding an infinite number of bytes is hard on your RAM. So the limit parameter gives you a way to stop after a certain number. Finally, you are allowed to use hash defined macros in your limit in case you were curious. In your limit. Yeah, makes sense. The if empty parameter. Now, this parameter defines what the embed result should be if the file exists but contains no data. Let's say that the file contains a single byte with the value 123. If you do this, we get 123. But what if the file foo.data that is 0 bytes long, contains no data, and then it will become 99. Notably, if the format is set to 0, then if empty will always be substituted. That is, a 0 limit will effectively means the file is empty. This will always say no matter what's in foo.dat. Now the prefix and suffix parameters. This is a way to prepend some data on the embed. Note that these only affect non-empty data. If the file is empty, neither prefix nor affix has any effect. Here's an example where we embed 3 random numbers but prefix the numbers 11 and 99 with suffix. There you go. Example result, boom bam. Now there's no requirement that you use both suffix and suffix. You can use both one and the other or neither. You can make use of the characteristic that these are only applied to non-empty files to that neat effect as shown in the following example, shamelessly stolen from the spec. So let's say we have a file foo.dat that has some data in it, and we want to use this to initialize an array, and then we want a suffix on the array that is a 0 element. No problem, right? Suffix 0. If foo.data has 1, 11, 22 and 33 in it, we get, yeah, but wait, what if foo.data is empty? Then we get, that's not good, but we can fix it like this. Yeah, since the suffix parameter is omitted if the file is empty, this would just return, which is fine. So hash embed to entry. Now this is a great way to test if a particular file is available to be embedded and also whether or not it's empty. So here's a chunk of code that will get 5 random numbers from the random number generator character device. If that doesn't exist, it tries to get them from a file findIm.data. If that doesn't exist, it uses some hard-coded values. Technically, the hash embed identifier resolves to one of those 3 values. SGDC embed not found. It is found, but is not empty, and it is found, but it is empty. I have good reason to believe that not found is 0, and the others aren't 0 because it's implied in the proposal and it makes logical sense. But I'm having trouble finding it that in this version of the draft spec. So those are draft specs to do. Other parameters, a compiler implementation can define other embedded parameters on its wants. Look for these non-standard parameters in your computer document. For instance, frotslamp. This might commonly have a prefix on them to help with namespacing. Now, it might be sensible to try to detect if these are available before you use them, and luckily we can use hash embed to help us here. Normally, hash embed will just tell us if the file is there or not, but and here's the fun bit, it will also return false if any additional parameters are also not supported. So if we give it a file that we know exists as well as a parameter that we want to test for the existence of, it will effectively tell us if the parameter is supported. What file always exists? The null file. Oh yeah, turns out we can use the macro file, which expands to the name of the source file. That difference, that file must exist or something is seriously wrong in the chicken and egg department. Let's test the fourth parameter to see if we can use it. So embedding multi-byte values. What about getting some ints in there instead of individual bits? What about multi-byte values in the embedded file? This is not something supported by the C20 standard, but there could be implementation extensions defined for it in the future. Next, we come to the pragma directive. This one is funky, short for pragmatic. You're going to do well anything your compiler suppose you're doing with it. Basically, the only time you're going to add this code is if some documentation tells you to do so. The non-standard pragma. Here's one non-standard example of using pragma to cause the compiler to execute a for loop in parallel with multiple threads if the compiler supports the OpenMP MP extension. So what is this? What is OpenMP? Learn OpenMP. Can I see about? Oh, okay. So these are all kinds of hash pragma directives documented across all 4 corners of the globe. All unrecognized hash pragma are ignored by the compiler. Standard pragmas. Now there are also few standard ones, and these start with STTC, follow the same form, on or off. So the on-off portion can be either on, off, or default. So yeah, OMP parallel for and for loop here, I guess. Now the on-off portion can be now FP contract, and the pragma name can be one of these, allowing floating point expression to be contracted into a single operation to avoid rounding errors that might occur from multiple operations. Set to on if you plan to access the floating point status flags. If off, the compiler might perform optimization that cause the values in the flags to become consistent or invalid. CX limited range set to on to allow the compiler to skip overflow checks when performing complex arithmetic. Defaults to off. So for example, do that. As for CX limited, the spec points out the purpose of the pragma is to allow the implementation to use the formulas where the pragma can determine they are safe. Underscore pragma. There is another way to declare a pragma that you could use in a macro. So hash pragma unnecessary codes. This can be used in a macro if need be. These are equivalent. Oh, these two are equivalent. Oh, okay. Underscore pragma. Now the line directive. This allows you to override the values for dunder line and dunder file if you want. I never wanted to do this, but K and R2 they write for the benefit of other preprocessors that generate C programs. So maybe that's that. To override, I want to read the Bible of C. So maybe that's that. To override the line number to say 300, and dunder line will keep counting up from there. To override the line number and the file name to this hash line, boom. The null directive. A hash on a line by itself is ignored by the preprocessor. Now, to be entirely honest, I don't know what the use case is for this. I've seen examples like this, which is just cosmetic. The line with the heart can be delayed with no ill effect, or maybe for cosmetic consistency like this. But with respect to cosmetics, that's just ugly. Another post mentions elimination of comments, that in GCC, a comment after a hash will not be seen by the compiler, which I don't doubt. but the specification doesn't seem to say this is standard behavior. My search is for rationale aren't bearing much fruit, so I'm going to just say this, I'm good old-fashioned C esoterica. So that ends with our article reading for beach.dev. I would love to go on with the articles, but for now I have paused it and I'm moving this type of talk and recording towards behavior modification. And maybe after behavior modification, like I said, I would go to Bible of C. Who knows? It could be something else, or maybe collective, the archetypes of the collective unconscious. Who knows? It could be any book, right? Or maybe I'll come back to this. Only destiny knows, right? So yeah, that's it for me. And if you guys want to check out my project, my prototype that I've used, and I'm still working on it, right? You guys can go and click the link under in the description below. So the link to this resource will be there in the description below. So yeah, thanks for watching and